Assalamu alaikum. I'm Dr. Wael Muhammad, PhD in Applied Mathematics from Egypt for Edexcel International AS Pure Math 1, Chapter 3, Equations and Inequalities. We can divide this chapter into three main points. First point is we have three different cases for solving simultaneous equations. One of them is linear and the other one is quadratic. And we should follow the following steps when we solve these problems. First step, we will take x or y from the linear equation and substitute by it in the quadratic equation. So we will eliminate one of them, and of course we prefer to eliminate the linear variable. When I say linear variable I mean to eliminate the variable with power 1. Second step, we will rearrange the result of the step number 1 onto the form ax squared plus bx plus c equals 0, or ay squared plus by plus c equals 0. And then, according to the discriminant of the quadratic equation, we can find the relation between the straight line, which is represented by the linear equation, to the curve, which is represented by the quadratic equation. The first case, b squared minus 4ac, will be positive, and then we have two real solutions, and this is graphically will be as following. The straight line will cut the curve into 2 points, like this. In the case of b squared minus 4ac equals 0, as we know, we have one real solution. So in this case, the line will be tangent to the curve. So the line will touch the curve at just 1 point, like this or this. And finally, the third case, b squared minus 4ac will be less than 0. And in this case, the line will not cut the curve nor touch it. Or we can say the line will be away from the curve. This is the first point. The second point is talking about how to solve quadratic inequality. In this case, the first step is to rearrange the inequality in the form ax squared plus bx plus c more than 0 or less than 0, such that we must make a positive. Try to make a, which is the coefficient of x squared, positive. And in the second step, we will replace the inequality sign to equal sign and solve it as an equation. And if we suppose that the solutions or the roots of this equation is m1 and m2, the third step is to draw a number line to represent your solution. I will write m1 here and m2 here. And since we choose a to be positive, we are sure that the curve will be at a smile face, or its open will be upward. And then we have three intervals now. Either the interval which is x less than m1 here, and in between the two roots, which is x more than m1 and less than m2, and the third interval which is x more than m2. The interval in between the roots represent this expression less than 0. So if we will solve this expression less than 0, I will write the solution as x more than m1 and less than m2, which is in between the two roots. But if the quadratic expression should be more than 0, we will choose the intervals on opposite sides from here. X less than m1 or x more than m2. This is the second point. The third point is talking about the region and the point of intersection of two curves. And I want to remind you by the following. When we have x plus 2 less than or equal 3, we call it an inequality, linear inequality with just one unknown. And to solve it is very easy, of course. I will say x less than or equal 1. But to represent this solution graphically, we will shade the point at 1 and choose all the interval which is left to it. And we call this representation half line. It's a very interesting name, half line. Okay. But if we take two variables, inequality with two variables, x plus y less than or equal to. In this case, we will draw the line x plus y equal to as a first step. If we want to represent this solution graphically, start with drawing x plus y equals 2, and it's very easy because I can take any 2 points on the line and join between them. If x equals 0, y equal 2, and this point here, and if y equals 0, x equals to this point here, and we will join between them to get this line. And then you should know that this line divides the plane or the points on the plane into three main parts. On the line itself, on the line here itself, we can say that all the points on this line satisfy the equation x plus y less than. This point is 2 and 0, this point is 1 and half, this point is 1 and 1, and so on. All the points on this line satisfies the equation x plus y equals 2. And for the upper area here, or we can say half plane, the upper half plane, we can say that x plus y more than 2. If you choose any point in this area, you will find that the sum of two coordinates x and y will be more than 2. And this half plane here at which x plus y less than 2. If you choose any point here, you will find that the sum of x and y coordinates should be less than 2, as the origin 0 plus 0, as 1 and half, and so on. So if we look at the problem here, x plus y less than or equal to, so we will take this region and also we take the points on the line. This is the solution graphically. But what happens if we add more conditions, or we can say system of linear inequalities? I will add x for this inequality, x more than or equal 0 and y more than or equal 0. In this case, we make more restrictions on the region because we will take only the positive x values and the positive y values. So I will take the intersection between this region and the right half plane and the upper half plane, and this is the solution in this case. And we can say that the solution represents bounded region. Also, if I have quadratic inequality like this, if I want to solve y more than or equal x squared graphically, it's very easy. I will draw y equal x squared, and of course we know that this is the parabola like this is the curve, and then according to the sign of inequality I will choose this region. And we can say the same scenario as we said on the straight line. This curve will divide the points in the plane into three parts: the point on the curve, the points up the curve, and the points below the curve. And according to the problem, I will choose the points which its y is increasing 1, 2, 3 like this here, this region. Final situation, if I have a quadratic inequality and a linear inequality like this. So we'll draw, this is the curve here and this is the line, and I want to shade the area which is up of the curve and below the line. Up of the curve here and below the line, which is this area. And how we can get the point of intersection, because they are very important, we can solve them simultaneously. By eliminating y here, I can say x plus x squared equals 2, and then rearrange the equation and factorize it to get these 2 points of intersection. Let's go to the past paper problems. Question number 1. 2kx minus y equals 4, 4kx plus 3y equals negative 2 are two simultaneous equations where k is constant. A, show that y equals negative 2. Okay, if we look at the problems here, I can multiply 2 times equation 1. I will name this equation 1, and this is the second equation. So by multiplying equation 1 by 2, we will get 4kx minus 2y equals 8. We can call this equation 3. We can write now equation 3 minus equation 2. And then we have 4kx minus 4kx, they will be cancelled. Negative 2y minus 3y, I will get here negative 5y equals 8 minus minus 2, which will be 10. In this case, by dividing by negative 5, y will be negative 2 as the question required. B, find an expression for x in terms of the constant k. Okay, I will take the value of y here and substitute by it in the first equation. So I can write here 2kx equals 4 plus y, because I will move negative y here with positive sign, but y is negative already, so it will be 4 minus 2, which is 2. I can cancel this 2 to be 1 here, divide by 2 here, divide by 2 here, and then x can be represented as 1 over k. Okay, question 2, solve the simultaneous equations. X plus 2y equals 3, x squared minus 4y squared equals negative 33. Okay, from this equation we can represent x in terms of y like this, 3 minus 2y, and by substituting here we can replace x with 3 minus 2y all squared minus 4y squared equals negative 33. squaring the first to get 9, and then 2 times first times second to be negative 12y, then plus second squared, which is 4y squared, minus 4y squared equals negative 33. We are lucky because we can cancel this negative 4y squared with this positive 4y squared, and then we have negative 12y equals negative 33 minus 9 to get minus 42. So y will be 42 over 12. We can divide by 6 here to get 7, divide by 6 here to get 2. Okay, and to get the corresponding value of x, we can substitute here in the first equation to get the value of x. X plus double y, which is 7, equals 3, so that x will be negative 4. Given the simultaneous equations, x minus 2y equals 1, 3xy minus y squared equals 8, show that this equation. Okay, of course, from the first equation we can write x equals 1 plus 2y, and then here I can write 3y bracket 1 plus 2y close the bracket minus y squared equals 8. Expanding this bracket to get 3y plus 6y squared minus y squared equals 8. Rearrange the equation to get 5y squared, and then plus 3y minus 8 equals 0. Then 4b, we will factorize this expression here, 5y plus 8 times y minus 1. So either y equals negative 8 over 5 or y equals 1. Don't forget that x equals 1 plus double y. So in the first solution here, x equals 1 plus double y, which is negative 16 over 5. This will be 5 over 5. 5 minus 16, it will be negative 11 over 5. Or we can say for the second solution, x equals 1 plus double y, 1 plus 2, which is 3. So the solutions either negative 11 over 5 and negative 8 over 5. The second solution will be 3 and 1 plus 1, which is 4. Okay, 4a, by eliminating y from the equations, show that the following. Okay, from the first equation we can rewrite it as y equals 2 minus x. Replace each y here with this, so we can write x squared plus x times 2 minus x, and then minus 2 minus x all squared equals negative 1. X squared plus 2x minus x squared. Here we should expand the perfect square and then multiply by negative, don't forget. So we have here first squared 4 minus 4, and then minus 2 times 2 times x minus 4x to be plus 4x, and finally plus x squared, no, negative x squared equals negative 1. After simplifying, x squared can cancel negative x squared, and then we have negative x squared here. 4x plus 2x equals plus 6x, and then negative 1, positive 1 here, minus 4 minus 3. By multiplying by negative, we can find it as x squared minus 6x plus 3 equals 0 as the required. B, hence or otherwise solve the simultaneous equations. Okay, giving x and y in the form a plus or minus b squared of 6, which means that we can't factorize this equation, and so that we can write a equals 1, b equals negative 6, and c equals 3. Applying the general formula, it will be 6 plus or minus square root of 24 all over 2. We can simplify this square root to be square root of 24, which is 6 times 4, 2 root 6. Okay, and then we can write x as 6 over 2, which is 3, plus or minus 2 divided by 2 will be 1 root 6. And in this case, the corresponding y will be 2 minus x. So y will be 2 minus 3, minus or plus, do you know, I will multiply the positive to be negative and the negative to be positive, square root of 6. So the answer should be y equals negative 1 minus or plus square root of 6. 5a, given that 3 power x equal 9 power y minus 1, show that x equals 2y minus 2 piece of cake, because we will rewrite the right hand side to be 3 power 2 all to the power of y minus 1, and since base equal base, then power equal power, which means x equals 2y minus 2, because we will expand 2 in this bracket, 2y minus 2, which is required. For b, 2y minus 2 all squared is equal to y squared plus 7. Square of the first will give us 4y squared minus 2 times first times second will be minus 8y, and then plus 4 equals y squared plus 7. Rearrange, we have 4y squared minus y squared. Y squared will be 3y squared minus 8y plus 4 minus 7 will be minus 3 equals 0. Factorizing to have 3y, and y3 can be 3, and here 1 negative 9y plus y will be negative 8y equals 0. So that either y equals negative 1 over 3 or y equals 3. In the first case, x should be 2y minus 2. So x here will be 2y minus 2 over 3 minus 2, which means minus 6 over 3. It will be minus 8 over 3. And here x will be 2y minus 2, which means 6 minus 2, the result is 4. 6. Solve the simultaneous equation. Okay, from here we can write x equals 3 minus 2y, and here we can replace x with 3 minus 2y all squared minus 2y plus 4y squared equals 18. Expanding this perfect square to be 9 minus 2 times 2 times 3, which is 12y plus 4y squared minus 2y plus 4y squared equals 18. Rearrange 4y squared with 4y squared, we have 8y squared minus 2y minus 12y minus 14y, and then we have here 9 minus 18, which is minus 9 equals 0. Factorizing to get 4y minus 9 times 2y plus 1 equals 0. So either y equals 9 over 4 or y equals negative half. For each y we have a corresponding x. X equals 3 minus double y. So here x will be 3 minus 2 times 9 over 4, which is 9 over 2, to be 6 over 2 minus 9 over 2 will be minus 3 over 2, and here x will be 3 minus 2 times negative half, it will be plus 1 to be 4. Question 7. The curve and the line given by the equations. This is the curve equation, this is the line equation, where k is a non-zero constant, intersect at single point. Single point here refers to b squared minus 4ac equals 0. Find the value of k. Very good. From the linear equation, we can write y to be 1 plus k over 2x. Replace it with y here. So in the first equation, we can write k x squared minus x multiplied by y, which is 1 plus k over 2x. And then plus k plus 1x plus k plus 1x equals 1. Expanding, kx squared minus x minus k over 2x squared plus kx plus x equals 1. Kx squared minus k over 2x squared, something like 1 minus half, right? It will be k over 2x squared. And then minus x plus x can be cancelled, and we have only plus kx, and minus 1 equals 0. So that a is k over 2, b is k, and c is negative 1. Then we can write here b squared minus 4ac equals 0, implies that b squared, which is k squared, minus 4a, which is k over 2, and then c, which is negative 1, should be 0. K squared, negative, negative, positive, 4 over 2 will be 2, then plus 2k equals 0. We can factorize it to be k times k plus 2 equals 0, either k equals 0 or k equal negative 2. And the question said k is non-zero, right? So this will be rejected and this will be accepted, and this is the solution. K is -2. For the second item here, give the coordinates of the point of intersection. Okay, we can substitute with k equal -2 in this equation to be -2/2, which is -x squared, and then minus 2x minus 1 equals 0. We can multiply it by negative to be x squared plus 2x plus 1 equals 0, which means that it's x plus 1 all squared equal 0, and so that x equal -1. The corresponding y component can be evaluated by substituting with k value and x value in the linear equation. So we can write y equals 1, k is -2, -2/2 it will be minus 1 minus x. The corresponding y will be here y equal 1 minus x. X is -1, so it will be 1 plus 1, which is 2. So the solution will be -1 and 2. 8. Give your answers in set notation. A. Solve an inequality. Okay, for item A, it's a linear inequality. We can collect x together and the numbers together. 3x, we can write 3x minus x is more than positive 8 plus 13, right? To get here, 2x is more than 8 plus 13, which is 21. By dividing by 2, x should be more than 10.5, right? Don't forget that when we divide by a negative, we should switch the sign of inequality. But since we divide by positive, we keep the inequality sign as it is. The question said in set notation, so we can write x should be, or we can write solution set should be equals to set of all x such that x is more than 10.5. Okay. For B, solve the inequality. This is a quadratic inequality, so we try to solve the equation x squared minus 5x minus 14 equals 0. By factorizing, it can be x minus 7 multiplied by x plus 2, right? Equals 0, so that x equals 7 or x equals minus 2. We can consider this as x-axis, and then this is -2, this is 7, and this is our curve here, like this. This is positive, negative, positive. The question asks about what? About the positive, which is more than 0. Positive, okay? So we will write the two intervals on the opposite sides here, not the interval in between the roots. So the answer should be what? Should be x less than -2 and x more than 7. But in set notation, we maybe write the solution set to be set of all x such that x less than -2 union set of all x such that x is more than 7. Very nice question. 9. Find the set of values of x for which, okay, we can expand it at first to be x squared and then minus x minus 4x, it will be minus 5x, and finally plus 4 less than 2x minus 8, 2x minus 8. Very good. And then collect them together here, x squared minus 5x minus 2x, it will be minus 7x, and plus 4 plus 8, it will be plus 12 less than 0. Factorizing to be x minus 3 times x minus 4 equals 0 gives us x equal 3 or x equal 4. Again, this is x-axis, these are the roots 3, 4, this is the curve, and required to get less than 0. So we are searching for the interval in between the roots. So the solution should be x is in between the roots, x here between 3 and 4. 10a, use algebra to solve x minus 1 x plus 2 equals 18. Okay, we can expand x squared minus x plus 2x, which means plus x, and then minus 2 equals 18. x squared plus x minus 20 equals 0. In this case, we can factorize to be x plus 5 multiplied by x minus 4 equals 0. So we have x equal negative 5 or x equals 4. B, hence or otherwise, find the set of values of x for which more than 18. Okay. By the same scenario, we draw x-axis. These are the roots, negative 5, 4. This is the curve. We are searching for the positive because this is more than 0. So the answer should be these two intervals in the opposite sides. So the answer should be x less than negative 5 or x is more than 4. 11. Find the set of values of x for which 6x minus 7 less than 2x plus 3. Okay, piece of cake, of course. We can write 6x minus 2x to be 4x, and then less than 3 plus 7 to be 10. In this case, we can write x less than 10 over 4, which is 5 over 2, 2.5. B is a quadratic inequality, so we can factorize it to x here and x here. 5 should be here, and 1 here, both is negative. The roots will be x equals half or x equals 5, and by the same scenario, we are searching for less than 0, so we take the interval in between. So x should be more than half and less than 5. For part C, C is a very tricky question because 5 is less than 20 over x. Some students told me, okay, we can multiply by x to be 5x less than 20 and complete the solution, but this is wrong because we can't multiply by variable because this variable may be negative, and in this case we should switch the sign of inequality. To keep the sign of inequality, that is, we must multiply by a positive quantity, which is x squared. So after multiplying by x squared, the left hand side should be 5x squared is less than 20 over x times x squared, which can be simplified to 20x. So that 5x squared minus 20x less than 0, 5x common factor, and then we have x minus 4 less than 0. We can do the same. This is x-axis, these are the roots. We are searching for the negative part, so x should be more than 0 and less than 4. D, both A and B. The required here is to combine between the answer of A, which is x less than 2.5, and in the same time B, which is x more than half and less than 5. If you combine between them, we can say that this is the upper limit and this is the lower limit. So if we combine them, x should be more than half and less than 2.5. This is the answer of D. Very nice question. 12. Find the set of values of x such that 12. Find the set of values of x that satisfy this inequality, multiplying by x squared to get 8 only, and then plus x squared less than or equal 9x. Rearrange it to be x squared minus 9x plus 8 less than or equal 0. We can factorize it to be x minus 1 times x minus 8. Okay, we can write less than or equal, don't worry. We have to now draw the number line. Since we have less than or equal 0, x should be more than or equal 1 and less than or equal 8. 13. Find the values of k for which kx squared plus 8x plus 5 equals 0 has real roots, which means b squared minus 4ac should be more than 0. A is k, b is 8, c is 5, so b squared minus 4ac should be 64 minus 4 times k times 5 would be 20k more than 0. So we can say 64 more than 20k. Dividing by 20, k is less than 64 over 4 will be 16 over 4 will be 5. So k should be less than 16 over 5 or 3.2. Note that the question said real roots, so we can accept one root or two roots, so we can put more than or equal 0 here. So the answer should be k is less than or equal to 3.2. 14. The equation where k is a constant has no real roots, which means b squared minus 4ac less than 0. A is 2, b is 4k, c is negative 5k. So b squared will be 16k squared minus 4 times a, which is 2, times c, which is negative 5k, should be less than 0. We can divide by 8 to simplify these numbers. So we have here 2k squared and have here plus 5k should be less than 0. Taking k as a common factor, we have here 2 plus 5k less than 0. Again, we can draw the this is x-axis, these are the two roots. You are searching for the negative part, so the k should be in between negative 5 or 2 and 0, and this is the required here. Okay. 15a, sketch the graphs of y equals f of x, x squared plus 2x minus 15, and g of x is a straight line on the same axis. Okay. B, find the coordinates of any point of intersection. For a, let's collect all our data about the f of x. First of all, look at a. The sign of coefficient of x squared is positive, so we have a smile face curve. And then for the y-intercept, we can put x equals 0 to get y equals negative 15, and then try to get the x-intercept by putting y equals 0. To solve the equation with y equals 0, we can factorize it to be x plus 5 times x minus 3. Okay, 5x, yes. So we have here minus 5, and we have here 3. So we have 3 and 0. Finally, we can get also the turning point. To get the turning point, its x-coordinate should be in between these two roots. The distance between negative 5 and 3 is 8, so the midpoint is 4 away between negative 5 and 3. So negative 5 plus 4, which is negative 1. The x-coordinate of the turning point is negative 1. Putting negative 1 here, we can negative 1 all squared 1 minus 15, negative 14 minus negative 16. This is the turning point. Okay, for the g of x, which is the line, we have here 6 minus 2x. To get the y-intercept, put x equals 0, and of course y is 6. And if we solve this equation to be 0, 6 equal to x divided by 2, so x equal 3 and 0. Okay. Also, to solve b is useful for the sketching, to know the point intersection. To get the coordinates of point intersection, we can equate two functions together. So we can write here x squared plus 2x minus 15 is equal to 6 minus 2x. And after rearranging, we can write x squared plus 2x plus 2x plus 4x. And then minus 15 minus 6 minus 21 is 0. Factorizing to get x plus 7 times x minus 3 equals 0. So we have x equals negative 7 or x equals 3. In case of negative 7, we can get y to be 6 minus 2 times negative 7, which means 6 plus 14, which is 20. And of course, 3 is with 0, as we said. 3 and 0 is a common point here. Common point. Okay, very good. This is the straight line that joins between 3 and 0 and 0 and 6, and this is the curve passing through 0, 3 and 0 and negative 15, negative 5 and 0, and negative 7 and 20 is a common point here. Okay, and of course 3 and 0 is a common point, the other common point. The turning point is negative 1 and negative 15. The last item here is write down the set of values for x for which f of x more than g of x. Now these are the points of intersection, the x values of the points of intersection. In between these two roots, the line is higher than the curve, as you see here. But to the right of 3, the curve is higher, and to the left of negative 7, the curve also is higher. So the answer of C is x should be less than negative 7 or x more than 3. 16. Find the total values of x for which the curve with equation y equals 2x squared to x plus 15 is below the line with equation 8 plus 2x. Okay, so the y is the curve should be below y of the line, which means that 2x squared plus 3x minus 15 should be less than 8 plus 2x. After rearranging, we can write x squared 2x squared plus 3x minus 2x plus just 1x minus 15 minus 8 minus 23 less than 0. This expression can't be factorized, so we will solve this equation by the general formula negative b, which is negative 1 plus or minus square root b squared 1 minus 4ac to a times negative 23 over 2a, which is 4. Okay, and then as we know, we will draw the x-axis. This curve will be like this. This is the negative solution, this is the positive solution, and we have here less than 0, so we'll take the interval in between the roots. The answer would be, so that x is in between negative 1 negative square root of 185 all divided by 4 and less than negative 1 plus root 185 divided by 4. 17. On a coordinate grid, shade the region that satisfies the inequalities y more than this quadratic curve and y less than this curve. For the first curve, we have the following. Okay, it will be upward, and then if x equals 0, y equals negative 12. If we factorize it, it will be x plus 6 times x minus 2. Okay, so the x-intercept will be negative 6 and 0, and the other point will be 2 and 0. The turning point will be in between these two roots. For the second curve, we have the following informations. We have, of course, it will be downward, okay, because the coefficient of x squared is negative. If x equals 0, y will be 4, and we can factorize it to be 2 minus x times 2 plus x, which means that we have negative 2 and 0, and 2 and 0. Okay, for the first curve, these are the x-intercepts here. Okay, to get the turning point, it will be half distance between the two roots. From negative 6 to 2, we have 8, so the midpoint will be negative 2. If we put x equal negative 2 here, it will be 4 minus 8 minus 12, which means 4 minus 20 minus 16. Okay, negative 2 and negative 16, like here. So the curve should be make something like this. Okay, and move up again and meet y-axis at negative 12 here. Okay, and cut x-axis at 2 and 0. Okay, for the second curve, of course, it will be downward, as I told you, and then from 4 to negative 2, like this. The required is to shade the region which is more than the first curve. This is the first curve here, more than this first curve, and below the second curve here. So the required region will be this region, right? This is the answer. This is the region. Last question. A, on the coordinate grid, shade the region that satisfies the inequalities. Okay. Okay, for the first line, we can say y plus x equals 6. So we can get the easily 2 points 6 and 0 and 0 and 6, right? And we can join these 2 points like this. For the second line, we have here y equal to x plus 9, y equal to x plus 9. So the y-intercept, of course, will be 0 and 9. For x equal 3, 2 times 3, 6 plus 9, 15. And this is L2. For L3, y equals 3, which is a straight line parallel to x-axis. This is L3. Finally, x is more than 0 means the half plane right to y-axis, right? The required area is below the first line, below this line here. in this part, and then y is less than the second line in this area, and y more than 3 this area, and finally x is positive means this area. So L2 here is maybe not useful, right? This is the region here, this is our region, but take care that this is less than only, all of them without equal sign, so we should make it dash line. I have an idea here, I can make something like this, right? Of course, when you use the ruler it will be easy to draw it, but I here use the white color to overcome this problem. Okay, finally it's required to get the area of this shading region. We have here a triangle with the area of this triangle. Sorry, the area of this triangle is what? Half base times height. The base here from 0 to 3. This is the point 3 and 3 because 3 plus 3 is 6. Okay, so half times 3 times what? From 3 to 6 is another 3. So the area is 9/2 square unit. Okay, see you in the next chapter inshallah. Thank you and goodbye. Assalamu alaikum.